Okay guys, right, today we're going to learn about refraction, which is really similar to reflection in terms it's to do with light. This is to do with bending of light rather than reflecting of light. So once again, as we did last lesson, get yourself a power pack, cable goes in the red and black holes, get a nice beam of light using this little slit at the start. And you're going to take a glass block. They are glass, please be really careful about dropping them. And put that on your paper. And what you'll see is if you look very carefully at where the light goes in, as best we can on camera. Pause it. Right. So when I've just turned the lights off so you can see more clearly now. So we can see that when the light shines at the glass, it doesn't come out exactly where you want. So if I have my ruler here, I kind of expect the light to come out in this corner, but in fact, the light's coming out much further away down here. So it's not in line. If I put my ruler along again, I'd expect the light to pop out. And it doesn't. It actually bends as it goes through the glass. And it's very, very faint, but when you do your experiment, you might even see that it's actually, you can see the light bends as it goes through glass, because that's because light bends when it changes into a more dense object. And that's what we're going to investigate when we investigate refraction. So I'm going to show you how to do that. I'll just put the lights back on. So it's a little bit like we did before. This time I'm going to place my glass block. I'm going to draw a line where my glass block is. And I'm going to mark the dead centre where the light beam hits, and a little point there where the light ray's going in. And refraction is actually happening twice here, so I'm only going to measure it once. I'm then going to put a little dot on the back of the glass to show where it's coming out, just the one. And now I can take my glass block away, and I'm going to draw my line. So again, I'm not going to move the light just yet, so I can still see it. So I'm going to line up my light beam, that's my angle of instance, and just like before, I want to mark my normal line. So to do that, I'm going to put the protractor's dot where the glass block was, where the light beam meets, mark 90 degrees, and this time I'm going to do quite a big one and go through where the glass block was, literally top to bottom. And now I'm going to connect up my other dot where the light was. And now you can really see it. You can see how the light beam goes in, and it does not go. When there's no glass there, the light beam carries on, but when it's gone through glass, it's completely bent. And so what I'm interested in this time is this angle and this angle. Remember, this is called the normal line. So what's that angle? How much does it change by? And I'm going to look at different angles to see, and different materials to see how it has an effect. So remember to use the protractor, put a dot where the light beam meets, and turn it around so we line it up in line this time with my light beam that's going in, and measure round. And so this time that is working from the inside, 52 degrees. I'm going to do exactly the same. I'm going to turn it upside down this time and follow my light beam, making sure my dot is where the mirror and the light beam hit. And this time again, measure my angle round to the normal using the inside scale this time. So I start at 0 and it's 35 degrees. So there's a big difference, 35 and 52 degrees. So this is what you're going to investigate today.